Okay, so we want to do number 44, which says, sorry, number 44 in 4.1, which says what? I need to calculate the average rate of change between
1 is less than or equal to x.
1 smaller than x is smaller than 2,
Yeah.
right? Okay, so I'm going to modify this a little bit too, because I think it would be more enlightening if we had a bigger x range.
Yeah.
So I'm just going to slash the 2 here and put a 5. You guys okay with that?
Mm-hmm.
So if you want to do this later and get it right according to the back of the book, you'll need to redo. So picture first. What does this function look like?
Goes to 0, 1.
Okay, it goes through the point 0, 1.
But backwards.
But backwards. Well, yeah. So why do I think this one looks different than the...
It's 1/5.
It's 1/5, so this is talking about decay, right?
Yeah, it's less than.
So I draw something like this. It's like basically an exponential curve where I flipped over the x-axis, right? You guys see that? That flip over the x-axis is really me thinking about 1/5 to the x as 5 to the negative x. Shifting rules, right? To flip over the x-axis, I would introduce a negative into this thing before the rule.
Yes, sir.
So I take the 5 to the x function and flip it, right? Get this one. Guys how cool that? Okay. So where are my 2 points? Good. How did I get 0, 1?
All
As long
X
as
belongs to 0.
So if I plug 0 in there, I get some number to the 0 power, which is 1, unless the some number is 0, in which case I'd have problems. Not 0 things to the 0 power are always 1. Powers mean how many of these are you multiplying together, right? You aren't multiplying any of these together. Where does multiplication start? Starts at 1. Cool? Alright, so where are my 2 points I should be drawing? So I should go over 1 on the x-axis, and then over 5 on the x-axis. So I'm going to exaggerate this picture a little bit. It's not actually quite. This is a bad drawing.
Yeah.
Like a really horrible drawing, actually, because this is really, like, not in the right spot. You guys see why?
Yeah.
What's the y value for that one? That should be 1 comma 1/5. And I have 1 comma, like, basically 1, right? So I really dorked this picture up. This thing needed to be a lot steeper.
You could shift, or you could move the where 1 is.
Yeah, so I could slide 1 way out here. That would also work. You guys see that?
Yeah.
Okay. So I'm going to ditch that one for lack of confusion. Where's this other one? That's at 5 comma... Right, this should be 1/5 to the 5th power, right?
Oh, hold on, that's
1 over crazy number.
yeah, that's really freaking
Yeah,
small.
so that's 1 to the 5th over 5 to the 5th, right?
1
Which is 1 over
3,000.
5 times 5 times 5 times 5 times 5,
Not
right?
that part, you have less than 25, so why is it supposed to be 5? Not 1/5.
Oh, I crossed the 2 out. Yeah, that's actually a fair point. If I had 25 in here,
That's
that would be minuscule, right?
it's like a mole.
Yeah, because 5 to the 25 power is pretty much 0 for all engineering intents and purposes.
Yeah.
Okay, so this is my output, right? So my output is the output associated to 5 is 1 over 3,125. And now what?
Then you gotta play with games of fractions.
Yeah, okay, so now I'm supposed to get a slope, right? So I need the rise and the run. The run is easy. Right, the run is 4. And the rise is,
Minus something.
yeah, I don't know. How do I get the run?
1/5
You could write one fifth in terms of 3,000.
And then you multiply by.
Okay, so we're trying to figure out what? What 1/5 minus 1 over 3,125 is, right?
It's 625 over 3,000.
Okay, so that's 625 over 3125 minus 1 over 3125
Nice.
So it's 624.
gives you 624 over 3125, which is basically a fifth, right?
Yeah.
Why is this basically a fifth?
6
Because
into
if we
3
go
30.
down that much.
Because this is basically 0. You guys see that? One pizza split 3,125 ways is not a lot of pizza, right? If we had one pizza to share among the 20 of us, it wouldn't be a lot of pizza, much less that. So what's your ultimate answer here? What do you write? What's the slope?
Oh, it's over.
So your average rate of change is
Is that fraction over 4?
that fraction
Negative.
It's
negative that fraction, right? Because we're going down by that much. So negative 624 over 3125
over.
all over 4. And then is this a nice way to give your answer to people?
To you, yeah.
Well, you
No, you can.
Because you don't want us to simplify.
Yeah, I'll take this. If you want to give this to your boss at an engineering firm, you damn well better flip it over and give them an approximation, right? You guys see this? So what's your approximately equal to going to be?
So it's 624.
So remember, right, this is 4 over 1 on the bottom, so you can flip over and multiply. So you get negative 624 over 3125 times a quarter. And then maybe you can cancel.
So 12,000.
I would advise for trying to cancel first. Right, 624
Oh, it's 156. Okay.
is,
156.
what?
It is like 156.
Oh. So you get negative 156 over 3125. And how do you know those don't have any common factors?
They're either not.
Even an odd would tell you that they don't share 2 as a common factor. How about this?
When you're talking about
This thing is made out of 5 5s multiplied together, right? That's where I got it to begin with. This thing has not got any 5s in it because it doesn't end at 0 or 5. You guys see that? Cool. So in the end, I got minus 156 over 3125. Right? And the place I got that, right? So I went to my function picture and I said, what's the average change in output per input between the inputs of 1 and 5? Right? So there were 4 input increases between 1 and 5. Right? That was my run. And then the change in the output was minus 624 over 3125. Right? So I took that and split it among the 4 input increases. Cool? So the interpretation of this is that's how much your,
average root change.
yeah, what the average rate of change of your y was per x. You guys see that? So if my Y is pounds of plutonium and my X is years, this is in pounds of plutonium per year. Cool? Questions, Seals?